Section 770.125 of the National Electrical Code addresses the support requirements for optical fiber cables. It states that optical fiber cables installed in other than riser-rated cable trays shall be supported at intervals not exceeding 5 feet. In a scenario where fiber cables are installed in an existing utility tunnel on existing J-hooks that are 6 feet on center, it is crucial to understand the applicability of this requirement. Since the fiber cables are not installed in cable trays, the 5-foot support interval requirement of Section 770.125 does not directly apply. However, Section 770.125 also includes a general requirement that optical fiber cables shall be adequately supported to prevent damage to the cable. This means that regardless of whether the cables are in cable trays, they must be supported in a manner that prevents physical damage. The adequacy of the support depends on the specific installation conditions and the type of cable being used. Considering the installation of fiber cables on existing J-hooks that are 6 feet on center, it is important to assess whether this method provides adequate support to prevent damage. J-hooks are a common method for supporting cables in utility tunnels, and they can be suitable for fiber optic cables if properly installed and spaced. The key is to ensure that the cables are not subjected to excessive stress, bending, or abrasion. Factors to consider when evaluating the adequacy of the J-hook support include the weight and diameter of the fiber cables, the type of J-hooks used, and the environmental conditions in the utility tunnel. Heavier or larger diameter cables may require closer spacing of the J-hooks to prevent sagging or excessive strain. J-hooks with smooth, rounded edges are preferable to minimize the risk of abrasion or damage to the cable jacket. In addition, the utility tunnel environment may expose the cables to temperature extremes, moisture, or chemicals that could degrade the cable or its support system. Therefore, it is important to select J-hooks and cable materials that are suitable for the specific environmental conditions. To determine whether the installation of fiber cables on existing J-hooks that are 6 feet on center is in compliance with the National Electrical Code, it is necessary to evaluate whether the support system provides adequate protection against damage. If the J-hooks are properly sized and spaced, and the cables are installed in a manner that prevents excessive stress or abrasion, then the installation is likely to be in compliance with the National Electrical Code. However, if there is evidence of cable sagging, excessive bending, or abrasion, then the support system may need to be modified to provide additional protection. It is also important to note that the National Electrical Code is not the only standard that may apply to the installation of fiber optic cables. Other industry standards, such as those published by the Telecommunications Industry Association or the Insulated Cable Engineers Association, may provide additional guidance on cable support and installation practices. Consulting these standards can help to ensure that the installation is performed in a safe and reliable manner. In summary, while the 5-foot support interval requirement of Section 770.125 of the National Electrical Code does not directly apply to fiber cables installed in utility tunnels on J-hooks, the general requirement for adequate support to prevent damage does apply. The adequacy of the support system must be evaluated based on the specific installation conditions and the type of cable being used. If the J-hooks are properly sized and spaced, and the cables are installed in a manner that prevents excessive stress or abrasion, then the installation is likely to be in compliance with the National Electrical Code. However, consulting other industry standards and seeking guidance from qualified professionals can help to ensure that the installation is performed in a safe and reliable manner. In the context of electrical codes and standards, understanding the nuances of specific sections and their applicability is crucial for ensuring safe and compliant installations. Section 770.125 of the National Electrical Code, which addresses the support requirements for optical fiber cables, provides a clear example of how seemingly straightforward regulations can require careful interpretation based on the specific installation environment. When evaluating the support of fiber optic cables, one must consider not only the prescriptive requirements outlined in the code, such as the 5-foot support interval for cables in other than riser-rated cable trays, but also the more general performance-based requirements, such as the need to adequately support cables to prevent damage. In the case of fiber cables installed in a utility tunnel on J-hooks spaced at 6 feet on center, the initial question revolves around whether the 5-foot rule applies. As the code specifies that this rule applies to cables in other than riser-rated cable trays, it is important to determine whether the utility tunnel configuration meets this exception. If the cables are not installed in cable trays, then the 5-foot rule does not strictly apply. However, this does not mean that the installation is automatically compliant. The overarching requirement to adequately support the cables to prevent damage remains in effect. Determining what constitutes adequate support requires a comprehensive assessment of various factors, including the type of fiber cable, its weight and diameter, the type and spacing of the J-hooks, and the environmental conditions within the utility tunnel. For instance, heavier or larger diameter cables may necessitate closer spacing of the J-hooks to prevent excessive sagging or strain, which could compromise the integrity of the fiber. Similarly, the type of J-hooks used can play a significant role. J-hooks with smooth, rounded edges are preferable to those with sharp edges, as they reduce the risk of abrasion and damage to the cable jacket. The material of the J-hook should also be compatible with the environmental conditions, such as temperature variations, humidity levels, and exposure to chemicals. In addition to these physical considerations, it is important to account for the long-term effects of environmental factors on the cable and its support system. Over time, temperature fluctuations, humidity, and exposure to ultraviolet radiation can degrade the cable jacket and the J-hooks, potentially leading to cable damage or failure. Therefore, selecting materials that are resistant to these factors is crucial for ensuring the long-term reliability of the installation. Furthermore, the installation practices employed during the cable placement can significantly impact the adequacy of the support. Care should be taken to avoid over-tensioning the cables, which can place undue stress on the fibers and lead to performance degradation or failure. The cables should also be properly routed and secured to prevent them from rubbing against other surfaces or becoming entangled with other cables or equipment. In situations where the J-hooks are spaced at 6 feet on center, which exceeds the 5-foot recommendation for cables and cable trays, it is particularly important to conduct a thorough evaluation of the support system to ensure that it provides adequate protection against damage. This evaluation may involve visual inspection, physical testing, and engineering calculations to assess the stress and strain on the cables. If the evaluation reveals that the cables are not adequately supported, corrective measures may be necessary. These measures could include adding additional J-hooks to reduce the spacing, replacing the existing J-hooks with a more robust type, or implementing other support methods, such as cable trays or ladder racks. It is also important to document the evaluation process and the corrective measures taken to ensure that the installation meets the applicable codes and standards. This documentation can be valuable for future maintenance and troubleshooting purposes. In addition to the National Electrical Code, other industry standards and best practices may provide further guidance on the support of fiber optic cables. For example, the Telecommunications Industry Association publishes standards that address the installation and maintenance of fiber optic cabling systems. These standards may offer more detailed recommendations on cable support methods, spacing requirements, and environmental considerations. Consulting these standards can help to ensure that the installation is performed in accordance with industry best practices. Ultimately, the goal of cable support is to protect the fiber optic cables from damage and to ensure their long-term reliability. By carefully considering the factors outlined above and by adhering to applicable codes, standards, and best practices, it is possible to achieve a safe and compliant installation that will provide years of reliable service. In summary, the question of whether fiber cables installed in a utility tunnel on J-hooks spaced at 6 feet on center are in compliance with the National Electrical Code requires a nuanced analysis. While the 5-foot rule may not strictly apply, the overarching requirement to adequately support the cables to prevent damage remains in effect. Determining what constitutes adequate support requires a comprehensive assessment of various factors, including the type of fiber cable, its weight and diameter, the type and spacing of the J-hooks, and the environmental conditions within the utility tunnel. By carefully considering these factors and by adhering to applicable codes, standards, and best practices, it is possible to achieve a safe and compliant installation that will provide years of reliable service. Consider the broader implications of inadequate cable support in industrial and commercial environments. Beyond the immediate risk of signal degradation or service interruption, poorly supported fiber optic cables can pose significant safety hazards. Sagging or loosely hanging cables can become tripping hazards for personnel working in the area. In environments where heavy machinery or equipment is present, unsupported cables are vulnerable to being snapped or damaged, potentially leading to equipment malfunctions or even accidents. Furthermore, damaged fiber optic cables can release small glass shards, which can be irritating to the skin and eyes. In the event of a fire, damaged cables can contribute to the spread of flames and release toxic fumes. Therefore, proper cable support is not only essential for maintaining the integrity of the communication network but also for ensuring the safety of personnel and the protection of property. When designing and installing cable support systems, it is important to consider the specific requirements of the application. Factors such as the cable weight, diameter, bend radius, and environmental conditions should be carefully evaluated. The support system should be designed to provide adequate support without causing excessive stress or strain on the cables. It should also be resistant to corrosion, vibration, and other environmental factors that could compromise its integrity. In addition to selecting the appropriate support hardware, it is important to follow proper installation practices. Cables should be properly routed and secured to prevent them from rubbing against other surfaces or becoming entangled with other cables or equipment. The support hardware should be installed in accordance with the manufacturer's instructions and should be inspected regularly to ensure that it is in good condition. In some cases, it may be necessary to use specialized cable support systems to meet the unique requirements of a particular application. For example, in environments where vibration is a concern, vibration dampening supports may be used to minimize the risk of cable damage. In environments where space is limited, compact cable support systems may be used to maximize the use of available space. The evolution of fiber optic cable technology has also led to the development of new cable support methods. For example, some manufacturers now offer pre-terminated fiber optic cables with integrated support hardware. These cables can be quickly and easily installed, reducing the time and cost of installation. They also provide a consistent level of support, ensuring that the cables are properly protected. As technology continues to advance, it is likely that new and innovative cable support methods will continue to emerge. By staying abreast of the latest developments, engineers and installers can ensure that they are using the best possible methods to protect their fiber optic cables and maintain the reliability of their communication networks. Consider the impact of cable management practices on the overall performance and maintainability of fiber optic cabling systems. Poor cable management can lead to a number of problems, including increased installation time, difficulty in troubleshooting and repairing problems, and reduced airflow, which can lead to overheating and equipment failure. Therefore, it is important to implement effective cable management practices from the outset. One of the key principles of good cable management is to organize cables in a logical and consistent manner. Cables should be grouped together by function or destination and should be clearly labeled to facilitate identification. Cables should also be routed in a way that minimizes clutter and maximizes airflow. In addition to organizing cables, it is important to protect them from damage. Cables should be routed away from heat sources, sharp edges, and other potential hazards. They should also be supported at regular intervals to prevent sagging or strain. In areas where cables are subject to heavy traffic, they should be protected by conduit or other protective measures. Another important aspect of cable management is documentation. A detailed record should be kept of all cables, including their type, length, destination, and routing. This documentation should be updated whenever changes are made to the cabling system. Proper documentation can save a significant amount of time and effort when troubleshooting problems or making modifications to the system. There are a number of tools and techniques that can be used to improve cable management. Cable ties, Velcro straps, and cable trays can be used to organize and support cables. Label makers can be used to create clear and durable labels. Cable management software can be used to track and manage cable inventory. By implementing effective cable management practices, organizations can improve the performance, reliability, and maintainability of their fiber optic cabling systems. They can also reduce the risk of downtime and costly repairs. The integration of fiber optic technology into various industries has increased the demand for skilled professionals who can design, install, and maintain fiber optic cabling systems. These professionals must have a thorough understanding of fiber optic principles, installation practices, and testing procedures. They must also be familiar with the relevant codes and standards. There are a number of training programs and certifications available for fiber optic technicians and installers. These programs provide the knowledge and skills necessary to perform a wide range of tasks, including cable preparation, splicing, termination, and testing. Certifications demonstrate that an individual has met a certain level of competency and can be a valuable asset in the job market. As the demand for fiber optic technology continues to grow, the need for skilled professionals will also increase. Individuals who invest in training and certification will be well positioned to take advantage of the opportunities in this rapidly growing field. The continuous advancement of fiber optic technology presents both challenges and opportunities for the industry. As new technologies emerge, it is important for professionals to stay up to date on the latest developments. This can be achieved through ongoing training, participation in industry events, and reading technical publications. The challenges associated with fiber optic technology include the increasing complexity of cabling systems, the need for higher bandwidth, and the growing demand for reliability. However, these challenges also present opportunities for innovation and growth. By embracing new technologies and developing creative solutions, the fiber optic industry can continue to meet the evolving needs of its customers.